This is a movie from mathematical modeling minds about how you develop mass and energy balances for different systems. This is the outline of this video. First, I will give you some important terms that you need to know, and then the mass balance, energy balance, what are the different types of work associated with systems, and the energy balance for a closed system, energy balance for an unsteady open system, and finally the energy balance for an open system at steady state will be presented. Energy. Energy is the capacity to do work. It is the sum of kinetic, potential and internal energies. Kinetic energy. It is the energy associated with translational, rotational and vibrational motion of a system, and this is a macroscopic property. Potential energy is the energy associated with the system due to its position in a force field. This is also a macroscopic property. Internal energy is a microscopic energy on the atomic and molecular scale. This is a function of temperature and density of the system. Work is a force acting through a distance on a system. A system, it is an object or collection of objects whose properties we want to study. In closed systems, there is no mass inflow or outflow through the system boundaries. In an open system, mass crosses the system boundaries. Intensive properties are independent of the size of the system. Temperature, molar volume are some examples. Extensive properties are dependent on the size of the system, such as total enthalpy. Steady state is used to refer to open systems in which the inlet and outlet mass flow rates are invariant with time. In a system, rate of mass accumulation within the system boundaries is equal to the difference between the rate of mass flow into the system and the rate of mass flow out of the system. Mass balance can be replaced with molar balance if there are no chemical reactions within the system, because when there are reactions, number of moles can vary depending on the chemical components. This is the energy balance equation for a general system which has the components as given in this figure. The rate of energy accumulation is equal to the total energy flowing into the system minus total energy flowing out of the system plus rate of heat flow into the system plus rate of work done on the system. uhat is the specific internal energy of the system. V is the velocity and Gz term denotes the potential energy of the system. Qdot represents the heat transferred to the system through a conducting wall. Ws is the shaft work and Wec is the expansion and contraction work. First, let's take a look at expansion-contraction work. The work done on the system is equal to the force applied times the distance moved. It is also same as the work done by the system times the distance moved. Here, the work done by the system is represented with a negative sign because it is loss of energy to the system. If the force applied on the system is constant, we can represent W as F times delta X. Here, F applied is positive. But what about delta X? Because of the applied force, the volume of the system has reduced. So we represent that with a negative sign. If F is a function of X, then we can take the integral to compute the work done on the system. The force is equal to pressure times area, and hence we can write the expansion-contraction work as P into dV. So what is the shaft work? The work is being added or removed without a change in volume of the system. There is another type of work which is the work associated with flow. For example, when a tank filled with the fluid is opened through a valve, the fluid that exits from the tank pushes the surrounding fluid doing work on the surroundings. In the same way, when high pressure fluid is flowing from surroundings into the system, the surroundings do work on the system. When a fluid is entering the system, it pushes into the system and the work is done on the system, which is positive and can be written as W dot equals F into X dot. X dot is the velocity of the fluid and velocity times the cross-sectional area is equal to V dot, which is the volumetric flow rate. As we are dealing with mass flow rates, we can write the V dot as mass flow rate times mass specific volume. Remember that P and V need to be specified where it crosses the boundary of the system. When fluid flows out of the system, the work is done on the surroundings and the work interaction of the system is negative. The new flow work is given by the difference between these two terms. Okay, so up to now we have derived the energy balance equation for a general system. Now we are going to look at how we can apply this for a closed system. In a closed system, there is no mass inflow to the system and no mass outflow from the system. Therefore, there is no energy flow associated with mass flow rates. A closed system interacts with the surroundings via heat work, shaft work, and expansion-contraction work. We can write the energy balance equation as given here. The energy balance for an open system. The general energy balance equation we used before is applied for unsteady open systems. But here, one more term is added to the equation, that is flow work. Because the system is open, the flow work is associated as well. Energy balance for an open system at steady state. What happens if the two mass flow rates are equal? Then there will be no mass accumulation within the system and it will be in steady state condition. So the energy accumulation term will go to zero. Further, in this type of systems, expansion-contraction work is not involved because usually the steady state balance is applied to rigid mechanical equipment which does not change the size of the system. Next, insert the flow work formula into the equation and rearrange it to obtain the enthalpy, which is equal to U plus PV. And you will get the final equation for energy balance for an open system at steady state. I hope you understood this session about mass and energy balances that are really important in mathematical modeling. If you have questions or concerns over the content of this video, please leave a comment. If you really like the video, give thumbs up and subscribe for the channel and press the bell icon for new video notifications. Thank you.